Okay, welcome to the second part of the online workshop number 4 about the basics of Python and backend development. So in this part, we'll be looking at just plain and simple Python uh, language syntax, and then we will touch the object-oriented and functional programming paradigms. These are, well, very important. They transcend any specific language. They are true for Python, JavaScript, and pretty much any other general purpose language. So these are like very relevant guidelines and paradigms to follow. So last time we were left here. So if you run it, it just says I'm alive or it's alive. However, you can also run it from here. Python 3 is the command, and we renamed it. I renamed it to basics.py. Basics.py. So this one also works, and you should also be able to just copy the full path and run it from just any terminal. So I think I need to put it in quote marks here. So yeah, it works from here as well. So about the basics of Python. So the assignment is just like that, and you can just print x or print y, and so as expected, it prints out the variables. You can of course reassign the variables in a very similar fashion. You can call functions on call methods on these variables. So let's see what's available for x. Conjugate, Jesus. These are all the functions that are available for x. Let's say negate should be a function. We can say that the new x equals the x negate. We can check what functions we have for the string, because y is a string. We can go capitalize. Awesome. So now we would have a negative x and a capitalized y. I mean, we have to assign to something, so like this. Oh, capitalized, just capitalized is the first letter. Awesome. I think it's something like upper. This one does the trick. Yeah, here we go. Okay, a function in JavaScript was something like this. And something. Python language is similar, but instead of function we use word def. Well, that's not a big difference. These braces we still need, but we don't need the curly braces, because everything that will be indented from the side, for example in JavaScript we would start writing here, and you can see it's indented from the side. So Python was going one step further and said that, well, if you are indenting from the side anyway, so we can just make it a part of the syntax. So say like this, and then we can just call my function, and this calling is similar. As you can see, we don't use semicolon at the end of the lines, because everything, the indentation is actually, the indentation means where each statement starts and each statement ends. Indentation is just this gap from the left side. So this one is just saying something because it just runs this function. And if statements, if I don't know, x is greater than 0, but we already know that it's not, then again indentation over here, then let's print my function else if is looks like this, elif we have to put something here, x equals 0, then I don't know, print 0, for example, or x, and else, I don't know, something else. We can print y. So this is a very standard if-else statement, similar to JavaScript. So in this case, x is -9, so it is not positive, it's not 0, it's here. So it prints out y, and y is ASDF, uppercase. For loops, we can do a quick list. One way to write a list is something like this, but another one is just list range, for example 5, and we will just call it. So a range just loops over just 5 times and prints out the number, so 0, 1, 2, 3, 4 should be like that. And what we can do is we can just print them out in a loop. For item in L print item should be 0, 1, 2, 3, 4. We can use string formatting like this. So item equals item. So if you use formatting, then you just use these curly braces to access any variables you might want to access. Bam. Okay, well, these are the very basics of the Python programming. We will get more into that just in a moment. So the next one we need to talk about is the object-oriented programming. So we can open a new file, op.py. Bam, here we go. And the object-oriented programming main takeaways is a class and an object. These two things are the most important things in object-oriented programming. So a class is a blueprint of something, let's say a car. It's not a specific car, it's a car. Well, how a car can look like. Say class car. Then we have to give it a function inside this class that will create the first real car, the first individual car, and that will be an object. And this function is called a constructor, and it exists in any language. It may be different syntax, but in here the syntax is like this, and we use self word because a self will be the individual car that we are looking at. So, and it will have a couple of variables. self color will be equal to something. Self weight will be equal to something, and self I don't know, mileage, kilometerage, I don't know, distance will be equal to something. To what will be a random car be equal to? Well, a distance should be like something like a 0 at first. A weight could be, well, we don't really know weight, and a color, we don't know these. So we will pass them in here. Color goes here, and weight, oh crap, weight goes here. So color and weight. And voila, we have a class. So this is how a car would look like. In this application, we would know, could have multiple cars, and each car would just have these three things here. So let's create a car. Some car equals car. At this point, we pass in a color and a weight. Let's say color is red because I like red color, and the weight is, let's say, in kilograms. And voila, we actually have our class and one instance. So once we run, once we call this function, it looks like a function call, right? Because it's in these braces, but it actually calls this init function. And a function inside a class is actually called a method because it operates inside of a class, and it has access to itself. A self is this particular item we are looking at. So this is the red car that has a specific weight. Maybe we can do something like license plate. License plate. So we can do, I mean, something like this. And now we have to add it over here as well, because now it takes 3 parameters. Even though it looks like it has 4 parameters here, the self, we don't pass it in. And for constructors in other languages, you just don't have this first parameter here. So let's say a license plate is license, something like that. So some car is a specific car. Class car is just a blueprint of what a car should look like. And now we can actually access some elements inside the car. So as you can see, we can access distance, for example. Should be 0. We can print it out. We can say f distance equals to this thing. I mean, to this thing. And let's see, distance equals to 0. We can say a color, maybe. All right, a color is, oh, distance, sorry. Color equals red. But an object does not have just this state, it also has its behavior, and behavior is some methods, some other methods other than constructor that a car can have. Let's say we have def drive, say it takes an argument distance, and what it does, it just adds distance, all right? So self distance plus equals distance. where is it? Over here. And should be okay actually. Oh, I don't have self here. Right, very good one. So all the methods must start, its first argument must be a self in Python. In other languages, it's not like that. So now what we can do, we can drive a little bit. We start by having distance 0. The car hasn't driven at all. But let's see, what do we have here? Oh, we have a method drive. Okay. And it takes a distance, as we can see. Let's say 99 kilometers. And we can see what is the color. The color shouldn't have changed, but the distance should have changed. So now the distance should be 99. And we can check what happens if we drive a bit more. Then the distance should be 99 and then something like 198. Bam, you see? Because, well, a car, this instance or object, some car actually saves its distance in itself. This value, distance, does not belong to a generic car. It doesn't belong to all the cars in the world. It just belongs to this one instance, this one specific car. And that's what object-oriented programming is in its essence. So there are classes and there are instances of those classes called objects. Okay, but it gets much more interesting than that. We can actually take a new one, OOP1.py. There are more to it. For that, I will try to create a couple of other scenario. So we will be dealing with animals. So we can start by class animal, and the class animal has its constructor. Here we go. We write self, and say an animal has species. All right, and well, what species is an animal? An animal is, well, I don't know, generic species, or we can just pass it in over here. I mean, species. Okay, and what an animal can do, let's say an animal can breathe. How do you spell breathe? Self print self species is breathing, and let's say it can move self something like this. Oh, that's a semicolon. Oh, it shouldn't be a semicolon. So, all right, but now we can call some animals. We can create some animals. So let's say a dog maybe equals animal and we have to pass in a species. Let's say a species is a dog. Oh crap. And now we can call something like print dog breed. But we don't have to print it because it already prints here. So we just do this. And since that's a method, we can call it. Bam. Dog is breathing. Very nice. But for example, breathing is something that all animals do. However, but moving is different for different animal. A dog would run, a bird would fly, a fish would swim. So we don't really know how, in reality, we don't know how animal moves. So this is actually, so we don't know how this will happen. So it actually raises not implemented error because it's not done. It's not created. We don't know how a random animal moves. We have to pass in some sort of a move method how to do it. So now when we run move, it raises a not implemented error as expected, because we have to subclass this. We have to say that class dog animal is it's now a class of a dog, and it extends animal. It does anything that an animal does, but it also does something that a dog does. So in this particular case, def init, and it already provides you with the intelligent code completion. It takes species, but in this case we actually know species, and we just say that we will call a superclass. In this case, a dog is a child class and an animal is a superclass. We will call superclass init function with an argument dog. And now a dog is really a dog. So it's not just a random animal, it's a dog. And dog has a very specific move function. So we can go def move and now we can implement this move. A random animal doesn't have move, but the dog has a very specific move function. So it will just go self species is running. It's its specialty. And this, when we say that a dog inherits from animal, we mean that it takes everything that an animal has. Let's say this breathe function, this move function, but some of the functions it can override. And now it took both of these functions, but it overrides the move function with a specific version of the dog move function. And in this case, it's this running. And if we now instantiate this dog class, now we have an instance of dog, an object of dog, and the dog can move because it will call this specific function instead of this. So init takes one parameter. Which one is it? Oh yeah, we don't need to give the dog because a dog class already says that it's a dog. It already knows that it's going to be a dog. All members of the dog class are of species dog. So dog is running. So this works fine. We can say something other than that. We can say that we've got a bird, and the bird move function is, first of all, it's a bird, and second of all, it's flying, right? So a dog is this guy, but we have a bird who is a bird apparently, and if we call a bird move, then voila, we should be having a bird is flying. So a bird inherits from animal, and it's also said that bird extends animal. Bird. This is in object-oriented programming. It's called inheritance, but it's hard to think of it as inheriting something, because that would require to think of some parent and child relationship. A bird is not a child of an animal. A dog is not a child of an animal, and an animal is not a parent of something. A dog is an animal, just like a bird is an animal. Think of it as a relationship, and this would be something that you can Google as well. And this inheritance works as is a relationship. So a bird is an animal, a dog is an animal. But yeah, we can have actually some extra species here, and we can pass it in here and say that not all birds are of species bird, because I think the species go more narrow than a generic bird. So we can say that this guy is a specific bird, let's say a parrot, and now we would see that a parrot is flying. All right. A class that implements everything, like this move method, for example, that's known as a class. However, the class that has some of the methods unimplemented, like this generic animal, it doesn't implement this move function. It's called an abstract class. Abstract because if you would have just instance of animal, there would be some limitations what you can do with that animal. As you saw in the some of the previous example, when the dog was an animal, it couldn't execute this move. So you cannot freely work with this particular object dog, because it cannot move. It will raise an exception, this one. So you cannot really, since you cannot work with it, it's abstract class. So let's return to this. So moving on, what you can do more is some little trick called polymorphism. I will quickly show you how it looks like. So let's suppose you've got you get a function that accepts animal. It just has to know that whatever will come in here in this argument, that will be an animal. And what this animal can do, well, it can move. We don't know what this animal will look like and what it will be capable of, but we know that if it will be an animal, then it must have a move function, a move method implemented. So anything that will pass in here will be an animal. This is a type hint. Anything we pass in here is an animal. And you can see that also when you use type hints, the code completion works. So now we can say that mover, let's comment these two because they print something. Mover, we can pass a dog here, and there shouldn't be any bugs, because even though a dog is of class dog, but remember, a dog is an animal, so all instances of dog is not just dogs, they are also animals. So if this function accepts an animal, well, a dog is an animal, right? So we can pass in a dog here. We can also pass in a bird here. Oh shit. But we shouldn't be able to pass in something like that, or something that's not an animal. It's a string. It will definitely not have this move function. String object has no attribute move, as expected. So using a subclass in a place of a superclass, this is called a polymorphism, because all the interpreter knows that all animals will have move function implemented, because you are more or less not allowed to use a generic animal because it's abstract class. You don't instantiate abstract classes. So everything that will not be an abstract class will definitely have move function implemented. So here you go. We can pass for a mover both animal and a bird. But this is sort of like object-oriented programming in its very core essence. There are much more to it, but inheritance, polymorphism, classes, objects, abstract classes is the basics of it. Yeah. But one thing that you have to think as well is something that goes orthogonal or against the inheritance, and that is composition. Composition is a programming concept that allows you to compose one object of many smaller ones. For example, if you think about it, a dog, well, it consists of something. It consists of, well, legs, a stomach, and a head, probably, right? So one could say that a dog has legs, or maybe limbs. And if it has limbs, it's actually a list of limb, a list of a limb. So we actually have to have a class limb. And this class should have something like which side this leg is. Say side, that would be something like left and right. And how would we call the front and rear? Other side. Okay, side on x coordinate and side on y coordinate. Let's say that. And yeah, so in this case, a limb would sort of know its position, and we would say where it is. And now a dog can have a list of limbs, so we will write it something like this. We have to create limb, and this one would be, say, side x would be, say, right, and front, And this one would be rear, left. All right, so the two last limbs are rear limbs. Okay, so this is the list of limbs for this wonderful animal. And actually, when we move, we kind of use those limbs, right? We actually can say that this particular limb has its representation as a string representation would be something like return self side x self side y. So when we try to print a limb out, it would actually call the string function now. So it will just print out both sides. And as we're moving, by moving, limbs, and now it's a list of these guys, and that would mean that it would print something like dog is running by moving right front, left rear, left rear, something like that. So we will pass it in to a mover function. Oh yeah, because it's in a list, the string doesn't work. We have to go representation. So we represent it as a string of self. Dog is running by moving right front, right rear, left rear. All right. Actually, also a bird has 4 limbs, so we kind of can move this up, but then again, it has wings, and wings are a bit different. So the front ones are actually wings, right? So this guy actually have self wings equal list of limbs. So these, let's say, are legs, and these are wings, and this is obviously both are front and right and left. Is flying is move, yeah, flying by flapping self wings. And now if we make the bird move, then this guy should say parrot is flying by flapping right front, left front. Okay, because these are the limbs. So this would be a composition. We can, in a similar fashion, add a head to it. Head. We will not implement it. Let's suppose it has eyes, ears, and everything else. And self head equals head. Yeah. So a dog has a head and a bird has legs, wings, and a head. And now this fellow bird, whoever will instantiate it and try to make a single instance of a bird, single object, will be provided with two legs, will be provided with two wings and a head. So it will be a bird would be composed of these things. So that's a composition. And whenever you can, then choose composition over inheritance. Yes. Okay, so this is sort of the basics of object-oriented programming. I was hoping to talk about functional programming as well a bit. Functional programming is also a very powerful tool, and why it's actually as old as object-oriented programming, but it wasn't so popular. But during the time when more and more parallel processes became available, and more cores are for the computers, and more concurrent processing happens, it's harder to remember what state each of these objects had. Let's say a dog has a name, all right, and we can say that self name equals name, and now it has a name, and many many processes simultaneously can try to change the name, and it becomes harder and harder to figure out at what stage each object has been left. Does this dog still has this name, or some process changed its name? Some parallel process changed its name, and too many parallel processes are working with the same objects. It's become difficult to manage that. So a functional programming saw its daylight again. So a functional programming sort of main paradigm is that functions are so-called first-class citizens. A first-class citizen is something that a function can accept or a function can return. So what does it mean for a function to accept a function? Well, this is a tricky one. I will show you, you will understand. Let's suppose inner function is something like this. I am an inner function, and we can pass this function to another function, wrapper function, and it accepts an argument, which is it will have one argument, and the argument will be some function, and it will print that I am an wrapper function, and then it will call the function that was passed into it. So here you go, you get this function, whatever it is, and it will just call it. So now we can call the wrapper function with some other function. What other function we could do? Let's take this one, inner function. So this is functional programming in action. You pass some function to another function, and that other function will call that inner function. I am a wrapper function, I am an inner function, but a wrapper function can also return something, and it can return an updated version of that function. So it's def updated function, An updated function could say something like print and now what this wrapper function returns? Well, it returns this function. So now it can accept a function and it can also return a function. It doesn't call it. You know that in order to call a function, you have to use those those braces in the end of the function. But if you don't, then well, it's just some object you can pass around, and that's what a first class citizen is. You can accept it as an argument, and you can return it, and that's the essence. So whatever the goal of the functional programming is to, by all means, avoid saving anything anywhere, because it can easily be overridden and overwritten by some other parallel process, because everything in a modern era is so parallelized. Everything runs simultaneously on 100 cores, so it's very difficult to follow that. So this wrapper function now returns some other function, updated function, and an updated function is the result of this one, so it will be this one. And now we can actually call the updated function multiple times. And it will each time return I am updated function and I am an inner function. Yeah, so first I am a wrapper function was called when we called this one, and then each time we called an updated function, it first called the updated functions, well, what that function adds to the inner function, well, that's this print statement, and then actual inner function, which is this one. So updated function, inner, updated inner. Okay, this seems probably not clear why we would want to choose this. It looks like a mess and it's difficult, and what's the fuss about functional programming? Let me show you some real-life examples where functional programming is at its prime. So suppose we've got something like a sum list. We would comment out these lines for now. And this list actually consists of some numbers. And suppose we want to have all those numbers that are even, and we want to have something like, we want to take the even numbers, so 2, 4, 6, and 8. And actually we not only want those even numbers, we also want to double them. So 4, 6, 12, and 16. So this is actually pretty normal use case. You have some list of some elements and you want to filter them. You don't want all of them, you want some of them. This is perfectly normal. And we just figure out some filter, let's say even numbers, but it could be some other filter. And you not just you want all of the original object, but you want some either parts of it. Let's say you have users, and out of all those users, you just want the user names, for example, not entire list of entire users, but only those users who are probably a year old or something like that. So both a filter and some sort of update to the original object. So without functional programming, you would do something like this: for sum list. Oh geez, now you have to have item in sum list, and if item, how to write this one, if modulus of item is not 0, then sort of continue, and we have to move it over there. And so this would be the filter modulus of 2, okay, and in that case we don't do anything if it is in fact even number, so modulus of that number is 0, then we want to return, but yeah, we actually cannot return, so we have to create an empty list which will be empty in the first place, and then we will have to append some elements to that. Append item times 2, and now we would have the filter, and now we would have also the update function over here, and we could print the new list, and this one should print something like 4, 8, 12, 16. All right, but in functional style it's a bit different. So we take a map. Okay, for the first time we take filter, and now we pass in a function that will be applied to each of those elements. So in this case it would be, we can create that function pretty quickly. Def it would be a filter function, and this filter function would return whether an item equals items modulus would equal to 0. So the first argument would be filter function, and the second argument would be the list, and then we also have a map here, and this map would also have some sort of a mapping function, map function, and the map function is just item times 2. So this is a mapping function. So for a map wrapper function we pass in the mapping function, for filter wrapping function we pass in the filter function, and finally all of this we put it in a list, and then we can say that new list equals this list. What we get from this, that the only place we ever save something is here. There is no intermediate state as here. Let's say after the first couple of 4 cycles the new list was unfinished, but it was already somewhere in the application unfinished. If at that point some other parallel process would look at it, it would just see unfinished new list, and it would just use the first maybe 2 elements of it, oblivious to the fact that it's not finished yet. So, but this one, it's either non-existent or it's finished. And now we can print the new list. It should be the same. Let's see. Do we have some errors? Oh, yeah, we do. Yeah, here we go. But we can do a bit better than that. instead of using these functions that are defined, we can use sort of undefined functions, which are anonymous functions. And both in Python and in JavaScript, also in other languages, these are called anonymous functions or lambda functions. Lambda I stands for item. So this is the function. This is the same function but written as a lambda expression. Because it contains only one line, we can have it like this. So this will return true. Just like this function. And only those who return true will be credited in this list. And this one is also a lambda function. That's the expression lambda I, and this is the body. So we don't need these anymore. This is one line instead of 1, 2, 3, 4, 5, 6 line, 4 lines here. This is a one-liner now. We filter it and we map it, and we collect it in a list, which is also not necessary. Something went wrong. Let's see. Yes, because over here we defined an I but used an item. There is no item. Bam, here we go. This one is the right answer. So this is where functional programming shines. Filter map, also there are some other built-in functions which the whole programming world constantly uses. But it's not so that the functional programming is completely different from object-oriented programming and they never cross. In fact, the modern programming consists both of object-oriented programming and functional programming hybrid. Both JavaScript and Python, as well as other languages, usually use some hybrid version of those two major coding styles. Okay, that was it for today, and hopefully next time we will actually manage to build our first API, link it to some SQL database, and then call those API services from JavaScript frontend. Good luck.